Welcome to Study Loop.
So say we have a substance like C4H10. Now, if we have something like that, what that means is that there are 4 atoms of carbon and 10 atoms of hydrogen in that formula. If we think about it in terms of moles, we can think the same way, that there's 4 moles of carbon and 10 moles of hydrogen for every mole of C4H10. But what if there's not 1 mole? So for instance, what if there's 0.0885 moles? Well, what we're going to do is we know that for every 1 C4H10, there's 10 hydrogens. So we're going to say, well, if we have 0.0885 moles of C4H10, there are 10 moles of hydrogen in every 1 mole of C4H10. So we're going to multiply 0.0885 by 10 over 1, and thus there are 0.885 moles of hydrogen in this sample. And we can do that with other substances too. So if we had 1.3 moles of CH4, well, you can see there's 4 H's in the formula. So there's going to be 4 times the amount of hydrogen than CH4. So we can take our 1.3 moles. And we can see by the formula that there's 4 moles of hydrogen in 1 mole of CH4. That's going to get us 5.2 moles of hydrogen. We can do this for 2.4 moles of C6H12. Well, there's 12 H's, so we can take our 2.4 moles and we can say that there's 12 moles of hydrogen for every 1 mole of C6H12. And we'll find that we have a total of 28.8 moles of hydrogen. And finally, if we deal with 1.87 moles of C8H18, well, there's 18 of our hydrogens there. So we can take that 1.87 moles and we can say, well, there's 18 moles of hydrogen for every 1 mole of C8H18. And then again, we just multiply those together and we wind up with 33.7 moles of hydrogen to 3 significant figures. So I rounded that 33.66 to 33.7 because we only have 3 significant figures here.